Hello everyone, my name is Lakshimi Chandra and I'm delighted to be here today to present my final project on topic of visualizing diabetes health indicators and analyzing factors for better diabetes management and prevention. Okay, now as we all know, diabetes is a chronic disease that affects millions of people worldwide and its prevalence is increasing rapidly. With this in mind, my project mainly aims to shed light on the factors that contribute to diabetes management and prevention. By analyzing health diabetes health indicators and visualizing them through graphs and charts, my research highlights the key factors that impact diabetes such as diet, exercise and lifestyle. I believe that my project is significant and relevant to today's society as it can help healthcare professionals and policymakers make informed decisions about diabetes management and prevention. Moreover, it can empower individuals to take control of their health and make positive changes to their lifestyle. So, without further ado, let me take you through my research findings and analysis. Thank you for being here, everyone, and I hope you'll find my presentation informative and thought provoking. So, before moving on to the next slide, the main contents I addressed in this project are given below. In this presentation, I will be covering several important aspects related to this project. The brief introduction, like about the diabetes and the problems associated with it, and also motivation in doing it, along with the approach using data visualization tools and algorithms. Lastly, I will also provide a further data analysis and showcase some results in the form of graphical representation. So let's go to the next slide. So, coming to the introduction, it's about the diabetes mellitus, generally referred to as diabetes, is a chronic metabolic condition characterized by high blood glucose levels caused and abnormalities in insulin production, insulin action, or both. So, moving on to the next slide. Problem. The purpose of this research problem is to study the factors that result in poor diabetes management and inadequate health outcomes in diabetics. This study is particularly helpful in investigating the correlations between different factors that contribute to diabetes and also other health conditions. The three research problems mainly explored in the study are: does average heavy alcohol consumption is significantly correlated with average diabetes prevalence across different age groups and genders? So, also, do age, BMI, and gender impact the prevalence of diabetes in different age groups? Is there any significant association between high blood pressure and the prevalence of diabetes among different age groups? Also, does having high cholesterol affects one risk of developing diabetes regardless of age or heavy alcohol use? So these are the questions mainly runs in everyone's mind. So I'm going to address all these questions in the further graphical representations. So the core motivation is the main slide. The core motivation of this study is to create powerful visualizations that could potentially help in the creation of strategies to enhance the management and treatment of the condition by highlighting its underlying trends and patterns of societal prevalence of diabetes. So, by analyzing these factors of diabetes, prediction models can be created to identify people who have a high chance of acquiring diabetes so that medical professionals can take preventative action to lessen the risk and also consequences that come with it. So, by further exploring the data visualizations represented in study, one may quickly gain insights into the correlations or associations between various factors and how they could be addressed to improve diabetes prevention and care. So, to the next slide, the approach. My approach is basically using the data visualization techniques that are algorithms and techniques. So the main tool used for visualizing the graphical representation is Tableau. So as I mentioned earlier, Tableau is a powerful visualization tool that helped me in creating different graphical representations in this project. So the bar charts, line graphs, bubble graphs, and word cloud graphs were used as the visualization tools to communicate the data effectively. Also, to effectively portray the synopsis and the keywords of the factors, I also use the word cloud graphs that are generated using a tool called Word It Out. Moreover, Microsoft Excel is also used to eliminate any extra columns or from the raw data set that might not be required for visualizations. So, moving on to the next slide. So, the results, analysis and approach. My first graph is about the average heavy alcohol consumption is significantly correlated with the average diabetes prevalence across different age groups and sexes. So, this statement is further addressed below. As you can see the figure, the bar graph in the figure shows the relationship between average diabetes prevalence and average heavy alcohol consumption. There is also age groups and genders mentioned in various colors for the better identification, whereas the x-axis depicts the average of both diabetes and heavy alcohol consumption levels. In this bar graph, the y-axis represents all age groups, whereas the x-axis depicts the average of both diabetes and heavy alcohol levels. The graph further allows to visualize the prevalence of diabetes and also heavy alcohol consumption within different age groups and genders in the population. I mainly picked a bar graph to depict the significant relationship between high levels of alcohol and diabetes prevalence in the population across all age groups and sexes. Since it allows for more effective comparisons and across various age groups and also easily applied to complex data sets, I use the bar graph. So you saw there are two color differentiations in the bars, that is the coding to differentiate between sex categories facilitates the easy comparison of the diabetes and heavy alcohol ratios among males and also females across age groups. Furthermore, the data shows that females in the age group 18 to 24 have higher ratio of diabetes prevalence than males. But after the age of 25, the male ratio becomes higher, as you can see in the graph. Whereas in heavy alcohol consumption, which is on the right side, the age groups of 18 to 39 have a higher ratio than males, whereas the ratios become approximately equal for males and females in older age groups. Overall, these findings underline the necessity of targeted interventions meant to lower the prevention of diabetes and excessive alcohol use in certain age and gender categories. So, moving on to my second graph, it's about the average of BMI and age for both male and females. This graph is a bubble graph that shows the association between BMI and age groups with the label age groups are given here. I choose the bubble graph mainly to represent this because the distribution of data for various categories such as age groups may be easily understood by using bubbles to depict data points. The size, as you can see, the size of the bubbles is proportional to the sum of BMI, giving a clear picture of the total BMI for each age group and making it simple to compare all the BMI levels between age groups. The graph's bubble size correspond to the BMI total, and also the age groups are shown in different colors on the right hand side. For your further investigation, the graph findings also show that the 53 to 68 age group has the greatest BMI, while the 18 to 24 age group has the lowest average BMI. This graph also demonstrates that BMI rises with age, which I will further correlate to see if the age, BMI and sex have an impact on the prevalence of diabetes or not. In the preceding graph, in the next graph, I'll show the relation between these three. So let's move on to the third graph. So here we can see, does age, BMI and gender impact the prevalence of diabetes in different age groups or not? To correlate the above, like the before findings with another graph, here I used a bar graph that can be used with age as the y-axis value and diabetes and some BMI as the x-axis values. And I filtered the diabetes ranges as 1 and 2 and also the gender. I created a bar graph because that makes it simple to compare the prevalence of diabetes and BMI in individuals of various ages and genders. Here the color coding is used, as you can see in the before graphs. I used the same colors as here for differentiating the female and male. So also again the bar graph facilitates the visualization and comparison easier, so I used again the bar graph here. And the BMI levels for different age groups and the genders, as well as the identification of patterns and trends in the data, are easier with the bar graphs. Furthermore, the graph results indicate that, as you can see in the graph, diabetes increased in the age group of 53 to 68 with an almost equal ratio of BMI from age 40 to 68. Furthermore, I also see the males have a higher BMI ratio in all age groups except for the 57 to 60 age group. The graph also shows that there is an increase in diabetes from 18 to 68 with a sudden fall in diabetes BMI from 69 to 79 based on the given data. So by analyzing the two graphs, we can say that there is a clear relationship between age, BMI and diabetes. So according to the bubble graph, BMI rises with age, with the 53 to 68 age having the highest average BMI recorded. So highest frequency is the same age range. The bar graph demonstrates that diabetes likewise rises with age. So it can be evident from this graph that males have higher BMI ratios than females in all age categories for those between 57 to 60 age. So this data imply that gender, age, BMI may all have a significant role in the development of diabetes. That implies type 2 diabetes is more likely to occur in those who have overweight or obese. This is because being overweight can make it harder for the body to use insulin correctly, which can result in high blood sugar levels and eventually diabetes on the other hand. So those who keep a healthy BMI and exercise or often have a decreased chance of getting type 2 diabetes. So I can say that there is a strong connection between BMI and diabetes, and keeping a healthy BMI might be a crucial step here. So moving on to the next slide. Here I identified another association between high blood pressure and the prevalence of diabetes among different age groups, which is presented in this graph. Here I used the line graph that depicts the relationship between age, average high blood pressure and diabetes that are on the x-axis, contains age on the y-axis, average high BP values are also on the y-axis. So here the use of color coding aids in distinguishing the different age groups which are on the right hand side in different colors. The graph also indicates that the high blood pressure increases with age, starting with 18 to 24 age people having an average of 0.2857, as you can see here in the blue color, and the people aged 45 to 52 having an average high blood pressure of 0.5224 here in the green color, and the value increases gradually with age until people aged 80 or old there also a value of 0.7130. So on the other hand, the prevalence of diabetes also increases with age. That is evident with a value of 0.2564 in the age group of 18 to 24, that gradually increased until the age group of 45 to 52 with an average you can see in the green color where 0.6372, and lastly the value increased until 80 or older with an value of 0.8065. So by using this line graph, it's easier to identify the trends and patterns in the data. So suggesting that pre-diabetes type 1 is found in people with high blood pressure, and type 2 diabetes eventually develops in those who have high blood pressure. This is easily evident by this graph. So as there is no further research also necessary to understand the underlying mechanisms, as I cannot have proper data until further research is done. There may be another cause of these relationships. However, my instinct is that there is a significant association between high blood pressure and prevalence of diabetes. So lastly, moving on to the my last hypothesis, thus having high cholesterol affects one's risk of developing type 2 diabetes, or regardless of age or heavy alcohol use. Here I used average high cholesterol and average alcohol consumption, two types in different age groups along with diabetes. So I used here a line graph. It provides insights into the relationship between age, diabetes, heavy alcohol consumption, high cholesterol levels. I used a line graph to visualize the relationship between age, diabetes, and heavy alcohol consumption and high cholesterol levels. This is because comparison, as I mentioned in the earlier slides, comparison is easier with the line graphs. Multiple variables like age, diabetes type, heavy alcohol consumption, and high cholesterol levels are easily compared here. Here my findings suggest that people aged 18 to 24 have an average high cholesterol of 0.3810 in type 1 diabetes, which is here clearly differentiated like 1 and 2. 1 is on the top and 2 type 2 diabetes is in the down. So on the other hand, the average high cholesterol for 18 to 24 years old with type 2 diabetes is 0.2949, which increases with age to 0.4299 for people aged 30 to 34 above. Similarly, the same graph shows a relationship between diabetes and heavy alcohol consumption. For type 1 diabetes, people aged 18 to 24, you can clearly see an average heavy alcohol of 0.04762, which also increased gradually to 0.06182 for people aged 57 to 60. So for type 2 diabetes, people have an average heavy alcohol consumption of 0.03682, which gradually increased like the same age of 30 to 34 and above with an average of 0.08917. Overall, I can say from the above values that there is a relationship between high cholesterol levels. As you can see, it is gradually increasing with age. So I can say that there is a relationship between high cholesterol levels and increased risk of developing type 2 diabetes. So also, as I earlier mentioned, further research may be required to establish the causal relationship between these factors, so as well as role in the age is evident or not. So for all, I can say that we can easily learn a lot about visualizations, as I have done with my problems and hypothesis, visualizing the data. I can say that different graphs types can be used to effectively represent various data sets. So while comparing data points across various groups such as age and sex, I use the bar graph earlier, and the bubble graph is also used as best tool for displaying how data points are dispersed toward different categories. Overall, the line graph on the other hand is useful for showing trends and changes in continuous variables over time. So moving on to my next slide, it's about the future work. The development of visualizations on the correlations between variables like family history, rate of diabetes is also, I think, crucial for extending our system, because in our data set the genetics are not included, which will be a crucial in the terms of diabetes. So genetics also plays a key role in diabetes occurrence. So dietary information might be also incorporated into the system as another possible expansion, because a healthy weight and the avoidance of chronic illness can be both achieved by healthy diet, which is required in the diabetes prevention. So, in conclusion, the analysis performed so far offers some insights into the associations across variables, but I think it also might be not sufficient to fully explain why these relationships exist, because therefore, um, an additional study is also required to explore other possible variations and factors that could have impact on the observed relationships. So, in order to develop a deeper understanding of the mechanisms and causes that underline them, I think, in my opinion, further study is also needed to improve the system. So, on an end note, I hope this presentation has been informative and insightful, and also look forward to any questions or discussions regarding the presentation. You can leave it under my video comments. So, thank you for your time and attention. Bye bye.